Welcome to day 2 of the forum. To view the agenda and take a note of all that we have in store for you, click on the drop-down menu we have on the top left corner. Hope you're all ready for this interesting session. Please welcome Mr. Sachin Jain, who will introduce our speaker for the day.
Distinguished guests, friends, ladies and gentlemen, it is with great pride that I welcome you back on the second day of our 9th annual Forevermark Forum. And as you all have been witnessing, it's happening in a phenomenal virtual platform that all of us are loving. I mean, just to reflect what all has happened. So day 1, which is yesterday, you heard from all our leadership team at De Beers, and there's enough reason for us to be positive, enough reason to look into the future and not just give up, already on this whole post-COVID world, but rebound back fast and really get back on track. So there's enough reason, enough confidence as at De Beers and at Forevermark, we will be doing more and more to ensure that we all are back straight to what the consumers really desire and their inherent need for expressing love, gratitude, and on which diamonds play a very important role. This session is actually very special, and I'm very glad that you all have joined us. We all talk about what diamonds do, and they bring that, that heartbeat increases and other things that happen emotionally. But more importantly, when we look into the future and look at the current millennial consumer, it's so important that even while we exist as an organization, as an industry, we stand behind for a purpose. We're doing something good. And there's a lot of discussion that we've done over the last couple of years around what diamonds do good and how we all as an industry need to stand behind what's really happening. And, if you reflect on the COVID world, which Stephen was mentioning yesterday and Paul also did, and we talked about that in this whole COVID time when the pandemic hit, the industry stood behind every workforce. We stood behind communities. We did whatever was required to be done, not just financially, but what was required to be done on ground. And I feel really proud again to be part of this industry here. But beyond that, there's lots of work that's happening behind the curtains. And that's really what we're going to be discussing today. When we talk about sustainability, when we talk about working with the communities, the environment, these are such important subjects. And we don't get to hear more about them often. And I'm very grateful to my 2 colleagues who've joined me from 2 different parts of the world. Katie, who's joining us from London, and my colleague Evelyn, who's joining us all the other way from Australia. But they will give us insights on not just the front-faced things that we have to do, but how as a diamond business we're doing better. So let me introduce my 2 colleagues to all of you. Katie Fergusson leads our social impact at De Beers. She's somebody who's working very closely on the areas of community, gender diversity, pushing these subjects of what are things that are right. And again, all the work that you do, Katie, gives us enough reason for all of us when we're facing the consumer that we have solid stories to talk about. And again, feel proud of what we sort of bring in. Katie holds a LLB degree, and also she's done a gender diversity program from the London School of Economics. Very happy to have you, Katie, on the platform. I also take this opportunity to introduce Evelyn to you. Evelyn has joined us from Australia. She's a geoscientist. She's been working on different areas, in De Beers and at Anglo American, and she's initiated this extremely special project. And I say this special because also, Evelyn, what you told me about the speciality of Kimberlites yesterday, and special why? Because when we look at Kimberlites that have the properties to hold diamonds, she's the one who realized that they also have the properties to hold carbon, and hence work towards making not just our company, but also the industry carbon neutral. And that's such a special project. She holds a variety of things that she's done in her educational career or in her educational span, but she got a PhD, which was co-awarded to her by MIT. But when I was reading about her, I was very inquisitive about 2 things, and they stood up. One was you also hold a BA double degree in Arabic language, which I thought was very interesting for somebody who's a scientist to do that. But also, Evelyn, she came 3rd in kayaking in Junior Olympics, and Katie and you and I both haven't done Olympics. She's the only one, so let's salute her that she's done that. It's great, Evelyn, to have you here. And also, between the 2 of you, you mentioned to me that you've lived in 10 countries, which is so cool, but also you lived in villages where you didn't have to worry about traffic lights, pretty much like the villages we have here. where life is more simple. But also, you mentioned where people are not putting locks on their doors, pretty much like we call Ram Rajya in India, which was an era where everybody had that faith. So it is with pleasure that I welcome you both on the platform. Over to you, and we're also excited to hear what really goes behind curtains and what's this phenomenal project that you guys are working on. Over to you.
Great, thanks Sachin for such a great introduction. And it is just wonderful to be with you all today, even virtually. So I thought I would start just by talking about why this project is such a priority for De Beers as part of our carbon neutral work, and why we're so excited about it. And I think many of you would have seen a real acceleration over the last few months of announcements from brands on sustainability, but particularly on carbon. And this is absolutely the right thing to do. It's increasingly business critical for every business, but we know that consumers care as well. Consumers want to buy they want to engage with purposeful brands, with brands that align with their values. And I think what we've seen over the course of the last few months and this really challenging global pandemic context is increasing engagement and reflection from people and from consumers on environmental issues, increasing time to really reflect on our relationship with nature, and what their expectations from brands, and I think in particular important for luxury brands, around issues like carbon and biodiversity. So in De Beers, when we talk about sustainability, we have a strong sustainability framework that is applied across our whole group and value chain called Building Forever. It's a really integrated approach. None of these issues sit by themselves, and none of these global challenges can be approached in a silo. It's focused around 4 pillars: protecting the natural world, partnering for thriving communities, standing with women and girls, and leading ethical practices across industry. And climate change, of course, sits within our protecting the natural world pillar. Now, when we look at our approach on climate change and how we're going to reach carbon neutral, there is, of course, no silver bullet on this. I think we all wish there were, but it is going to take a combination of approaches and technologies. And there's a lot of detail that sits underneath the work we've been doing on our carbon neutral approach. And it centers around 4 pillars. The first one is around reducing energy intensity, so really maximizing operational efficiencies. The second one is about replacing fossil fuels. The third one is about developing, buying and developing storage solutions for renewable energy. And we're incredibly lucky there that with most of our operations based in Southern Africa, there's a plentiful supply of sun and wind for us to harness for that. But the fourth pillar is really about new innovation and technology. And we know, and all carbon experts will tell us, that we are not going to become carbon neutral and really tackle climate change as a planet, as a global society, without investing in new innovation and new technology. So that really requires business partnering with government and academia to really step up and invest in these new potential solutions. And that's why Carbon Vault means so much to us. And Evelyn will talk about what carbon storage is, and a bit more about the technical solutions behind mineral carbonation. The reason that we call it and named it Carbon Vault is because it's a safe, non-toxic way to lock away the carbon within the rocks, within the kimberlite. And De Beers, even though the potential of the rocks like kimberlite to absorb carbon dioxide and lock it away in that non-toxic way has been known for a while. De Beers is the first company that has invested in a multi-year, multi-field research program focused on the potential of accelerating mineral carbonation within mine tailings. So we're very proud of this project. The early preliminary data will show us that this has the potential to be a very significant part of both De Beers and the diamond industry journey towards carbon neutral. And we are really lucky to have Evelyn with us today as the real sort of initial driving force behind getting this project set up. So with that, I will hand over to Evelyn.
Thanks very much, Katie, for that great intro. So I'm going to talk about more of the technical side. And for those of you who maybe don't know anything about carbon storage, I'm going to explain what that is. And then I'm going to talk specifically about carbon storage at mine sites, because there's some really special material at mine sites, which is the crushed up rock that we produce, that is just perfectly suited for carbon storage. And it would be great to find ways to take advantage of that. And then I'm going to give you a taste of some of the research and development that we've been doing since about 2017 on Project Carbon Vault. I still am on the steering committee for that project, so I stay close to it, even though I've moved on to a new position in Australia. And really, it's just a taste. So we could probably talk for hours about that R&D, at least I could, but we'll try and give you an idea of the spread of things that we're doing. And certainly, if you want more information, you can get in touch with us afterwards. On this slide, I've put some pictures of rocks. I'm a geologist, so I love rocks. And what I wanted to demonstrate with these photos is just to show you that the type of carbon storage we're talking about is really a natural process. Those top two pictures are kimberlites, and those are examples of carbon that's being stored in carbonate minerals that formed naturally in those rocks. And the bottom picture is showing some carbonate minerals that are forming in peridotite, which is one of the rare rock types that I studied for my PhD before I started working for De Beers. And it's a rock that isn't too different from kimberlite, it turns out. So I want to start by explaining carbon storage, because this is something that maybe we've all heard about, you hear it a lot in the media, but what is it? The way that I like to think about it is that it's a natural process. First and foremost, you learn in grade school about the carbon cycle, and carbon really does cycle around these different, we call them spheres of the earth. So you can think about carbon being in the earth and the lithosphere and the rocks, being in the oceans and the water, being in the plants, and being in the atmosphere. And there's a natural cycling there. And the problem that we have with climate change is that we're taking some extra carbon out of the lithosphere by burning fossil fuels, and we're putting that into the atmosphere too quickly. So what we want to try and do when we talk about enhanced or geoengineered carbon storage is we want to find a way to take some of that carbon back out of the atmosphere, put it back in the earth so that we can mitigate the harmful effects of climate change that we're experiencing. And the challenge is doing that fast enough so that we can actually be effective at mitigating climate change on the timescales that we need. And Katie alluded to this, but it's quite clear among scientists and climate change experts that no matter how quickly we transition to renewable energies, there's already too much carbon in the atmosphere, and it's going to be really challenging to switch to new technologies fast enough to prevent more buildup of carbon. So we're absolutely going to need some solutions where we can pull CO2 out of the air and lock it away. Now, when you read about carbon storage, there's lots of different options, but there's two main ones that people talk about, and the terminology can be a little bit confusing. So the first one is geological storage, and the second one is mineral carbonation. Now, mineral carbonation technically is also geologic storage, but generally these two terms mean something different when you see them in the scientific literature and in the media. So traditional geological storage, which is the focus of most carbon storage studies to date, is taking CO2 and you generally are putting it underground in some kind of porous rock formation, some kind of sedimentary basin, maybe an old oil well or an old coal bed or non-economic coal bed. And you're locking that CO2 away, but it's generally as a fluid. And if you look at the picture on the bottom of this slide, a challenge that we have with that is ensuring that it can be safely stored there and that it's not going to leak out and maybe get into drinking water or get back out into the atmosphere. And that's a really big challenge. Now, I think it can be done safely in many locations, but a lot of people are worried about that. And there's a lot of costs involved with sort of monitoring and making sure that that CO2 isn't moving around over time. Now, mineral carbonation, which is what we're investigating within De Beers, what you do is you still put that carbon back into the rocks, or you put it underground, but instead you convert it to a solid carbonate mineral. And you're locking that CO2 away in something that's non-toxic, it's safe, it's stable, and it's going to be stable for many thousands to millions of years. And you don't have to monitor it. You know it's going to stay there. So when we think about mineral carbonation, again, this is a natural process. So if you look at these two pictures here, the top one, these are the White Cliffs of Dover, and there's tons and tons and tons of carbon stored naturally in those cliffs. That is through the formation of carbonate-rich rocks such as limestone. You also get natural carbonate minerals in other rock types. So some rock types, when they weather, when they interact with water at Earth's surface, they will naturally take up carbon dioxide in veins as alteration minerals. And that's what you can see in the bottom picture. That's forming in one of the rare rocks that's similar to kimberlite, where you get these veins of carbonates that will form naturally. The problem with this for tackling climate change is that this process, this natural process, it typically takes thousands to millions of years. And we need this to happen in years, or better yet, in days or weeks or even hours. So we need to find some way to speed it up, and we'll talk more about that in a minute. Now, if you want to speed it up, it's best to start with a rock type where this process is already happening pretty quickly. So in most rocks, this happens really slow, but in some rare rocks, such as a rock called peridotite, which is the rock I studied for my PhD, and it turns out also in kimberlite, which is the really rare rock that's mined for diamonds, these minerals form much, much faster than in other types of rocks. So if you're going to try and speed this up, you may as well start with the best starting material. These rare rocks, this is a big word that you can tell your friends if you didn't know, they're called ultramafic rocks, and they're fairly rare. They're found on only about 1% of Earth's land surface. And the reason that they're really rare at Earth's land surface is that they diamonds, as you probably know, are formed very deep in the earth. And so that's why they represent a rock that's coming from much deeper in the earth. And when they come up to Earth's surface, where there are much lower pressure and temperature conditions, they're like a battery. They have this chemical potential to very quickly react with CO2 from the atmosphere and to lock it away so that they can convert to minerals that are more stable at these lower pressure and temperature conditions. I want to quickly put this slide up. This is a slide that was put together by a very famous scientist who's worked a lot in 2003. And he just summarized all of the options that we have to store carbon on the planet to try and deal with climate change. And what you have on the one axis is you have the storage time. So if you put the carbon there, how long is it likely to stay there before it gets back out to the atmosphere? And then there's the storage capacity, and that's in billions of tons or gigatons. So you can see there's all kinds of things on this plot. I won't go through everything in detail. You've got things that have to do with biology. You've got leaves and woody biomass, so trees. You've got carbon that gets stored in the soil. You've got carbon that's stored in the oceans. You've got something there called EOR, which is enhanced oil recovery, so that's putting it into oil wells. You've got underground injection, which you can think of as that traditional geologic storage. And then all the way at the top, in that top corner, you've got something called mineral carbonates. And that is long been called the holy grail of carbon storage because it's got the biggest capacity. You can put more carbon than you would ever need to store in there. Humans, just so you know, emit about 40 billion tons of CO2 per year. So you might want to end up storing something on, a few billion tons a year to try and deal with climate change. You've got more than enough storage capacity there, and it's going to stay locked away for the longest time. The challenge is, can we do it fast enough, and can we do it cost effectively so that we can unlock that incredible holy grail of carbon storage? So let's talk a little bit about carbon storage at mine sites. So it turns out ultramafic rocks are pretty rare on Earth's surface, but they're not so rare at mine sites because what is a mine? A mine is basically something that is targeting a rare rock that has something valuable in it. So it turns out ultramafic rocks, they contain diamonds, which is a luxury good, and also several commodities. Not all mines are ultramafic, but quite a number of them are. So for example, where you have platinum group metals, chromite and nickel, you often have ultramafic rocks. Some copper mines are ultramafic. There's a number of different things that come out of those. And when you mine ultramafic rocks, you break up the rock, and this is already enhancing what is already a pretty fast natural rate because you've increased that surface area so much that you can enhance those natural rates many, many, many times. And that broken up rock goes into something called tailings. It's generally stored in something called a tailings dam. And scientists have done research. They've been studying this for about 15 or 20 years in some mine sites around the world, very small scale academic studies before De Beers got involved. And they've realized that if you do some simple changes to how you manage your tailings, you can increase those rates even more. So we'll talk more about that in a minute, some of the options you have. And many ultramafic mining operations, they have the capacity to offset their emissions quite a lot. The challenge is doing that in a cost-effective way and figuring out how to scale up that technology. But certainly there's a huge amount of storage potential at many mine sites. And if you look at some mines, like the most dramatic example on this picture is Mount Keith Nickel Mine, which is a mine in Australia. You can actually see these things forming in the mine tailings. So this is happening unintentionally in the tailings. And what we'd like to do is understand this process as well as we can and figure out how to make it happen even faster. So for the last few slides, I want to talk about some of the details of Project Carbon Vaults, which is a project that I initiated and led for several years before moving to Australia last year. A really exciting project, and De Beers management impressed me so much by their interest in this project and their support of it. It has just been such a pleasure to work with De Beers on this. So this project was started in January 2016. It started very small with just some desktop studies, some literature review, and has grown to a very big project where we have research currently underway at all De Beers mines in Canada, South Africa, and Botswana. This will not apply to Namibia because those are found in beach sediments and they wouldn't be the right rock type. There aren't any ultramafic rocks there, but certainly all the other sites, it's applicable. And we are currently piloting technology, bringing it out of the university labs to a larger scale in Canada and South Africa. And we're working in collaboration with a big team of researchers from many countries, but the lead researcher that we've partnered with is Professor Greg Dipple at the University of British Columbia in Canada. And if you Google this project, you might see that it had a name change recently. It used to be called Project Monera, and it is now called Project Carbon Vault, which I think is a fantastic name. And this slide here is showing a couple pictures of some of these diamond mine tailings at some of our mine sites in South Africa and Botswana. So how do you go about studying mineral carbonation at diamond mine and figuring out how you might be able to accelerate and how much carbon you might be able to store? Well, we wrote a paper about this that came out in 2018, and I'm sure we'd be happy to share that paper with anyone who's interested. It was published in a peer-reviewed scientific journal with review from external scientists. But we sort of broke it down into 5 basic steps. So first step is you want to assess how many emissions are there, what's your target, what might you want to offset to be carbon neutral, or how much might you want to offset with this. And then the next step is to actually really study your tailings in detail and say, hey, is any of this going on already? What are the processes that are contributing this? What's limiting this? How can we speed this up? And that leads to step 3, which is where you do have to intervene to get a substantial offset with some kind of technology. And I'll talk more about that in the next couple of slides. But examples are things like you could inject CO2 like a flue gas from your on-site power generation. You could stir the tailings to get more atmospheric CO2. And you can do some clever things with microbes to get them to help you to increase some of the reaction rates. Then you need to monitor the carbon that's stored over time and verify it. And then finally, we need to make sure that anything we're doing to the tailings doesn't impede the rehabilitation that we have. And our studies to date have shown that it should be no problem. You should be able to basically rehabilitate the tailings as normal by covering them over with soil and vegetation generally. So how do you speed up carbonation rates? Well, there's a whole list of things that you can do. And when scientists think about this, they think about a triangle of 3 different chemical processes that are involved in this. So the first process is that you have minerals in your tailings that need to dissolve, and they need to contribute cations, such as calcium and magnesium, that are going to be able to react with CO2, which is one of the second parts of your triangle, to combine and form these carbonate minerals. And any one of these 3 parts of the triangle can be rate limiting. But generally what scientists find is that the CO2 supply is the first rate limiting thing. And if you increase that, you speed up these reactions. And then you hit the second wall, which is mineral dissolution, and then the third wall of carbonate precipitation. So those are generally the things you want to target in that order. So how do you get those different parts of the reactions to happen more quickly? Well, the first thing you do is you increase your surface area, you break up the rock. That's already happening as part of the mining. You can add heat or you can increase pressure. You can do that, but that adds costs, and you generally need to have a carbonation plant, and it tends to be really expensive. So those 2 we've sort of stayed away with in De Beers. We want to figure out what we can do that's simple, that's easy, that's cheap in the tailings. And then maybe down the line, as we understand these processes more, we could look at a carbonation plant that is more expensive and the technology is more advanced. You can also add CO2. So you can take your flue gas, for example, or you can just find a more effective way to get atmospheric CO2 to the minerals to react. You could add chemicals, not dangerous chemicals, but things that just are able to release those cations in exchange. And you can add microbes. For mine tailings, we're still in the early days of research, but what we've shown is that at low cost, something that makes sense to do now with sort of carbon pricing and the amount of money that you wouldn't put into this, adding CO2 and microbes are probably the most promising to do at low cost, and the other interventions would be a little bit more expensive. But as we do this R&D and as we discover new things, I think we'll learn more about that, and the costs of these things are expected to come down. So I want to show you some pictures of what we're actually doing with some material from our mine tailings. So the first slide I want to show you, these are some experiments that have been set up using coarse and fine mine tailings from Venetia mine in South Africa. And these are some scientific experiments that are being done at De Beers Technology. And they were started in February 2020, just before COVID. We managed to get all the international scientists in there just in time from universities in Canada and Australia to set up these experiments by working in partner with our South African scientists. Unfortunately, even with COVID, these experiments are still able to run. And what the scientists have done is they've taken big piles of tailings, and they've also grown algae, which consists of microbes that was actually taken from the kimberlite mine itself. So these are native microbes from the mine, and they've grown them into these big mats. And they're experimenting with physical, chemical, and biological enhancement technologies. And they are running these experiments for a full year to start with. And regularly samples are getting sent to the researchers so they can understand how much carbon is being stored, what's limiting it, what's going on with the reactions. And what's really exciting to me, this may seem like, this isn't at the mine scale yet, but previously this research was only done in test tubes in laboratories and universities. And this is really scaling it up in a big way so that we can start to understand what is going to happen with real material from our sites, which is really exciting. Here's a few more pictures showing some of those experiments and some of the scientists who are involved. There's all kinds of things stewing, and it's really, really exciting stuff. And they've just got the first batch of samples, and they'll be periodically sampling these experiments and writing up the results over the course of the next few months. It should be really exciting to see what comes out of this. And what will come out of this is that we'll learn what works, what doesn't, what's rate limiting, what the Venetia material is capable of doing, and it will give us some really clear guidance about which technologies are going to be the ones that we want to advance and which ones maybe need a little bit more work before we continue on. The second place where we have some work that is scaling up, which is really exciting, is Gahcho mine, which is located in Canada. And what they have done in Gahcho is really exciting. In August 2019, last year, they did the first kind of big field trial where they actually took carbon dioxide and injected it into some tailings to experiment to see what would happen if you took the flue gas from the offsite power generation and put that into the tailings stream. And that's really exciting. And in fact, the research was so exciting that the scientists, in partnership with De Beers and a couple of other mining companies, actually applied to the Canadian government for funding and were successfully awarded $2 million to continue this research and scale it up. And they were supposed to do that in 2020 with COVID. That has now been delayed to 2021, but the plan is to go forward with that next year with the partnership with the Canadian government, and that is really, really exciting. There's a news article there if you want to read a little bit more about that project, and again, we can send you some more information on that. So that is all the detail that I wanted to go into in terms of carbon storage and what we can do at mine sites. But I wanted to end here to just put this picture up. These are some beautiful paintings that were done a few years ago by an artist named Maggie Newman of Kimberlites. And I want to leave this image in your mind to remind you that kimberlites really are special. They're rocks that are sourced very deep in the earth. And when they come to Earth's surface, they bring us at least two gifts. One is they bring us diamonds. And the other one is that they have this amazing ability to soak up carbon dioxide from the atmosphere like a sponge. And I think it would be fantastic if in the future we could combine carbon storage with all of the other initiatives that Katie mentioned when she gave her introductory slides, so that at the end of the day, the only carbon that is coming out of a diamond mine is the diamond itself. Thanks very much.
We will now begin the Q&A session with the speakers. Minimize the full screen and drop in your questions by clicking on the Q&A icon, and our speakers will address them.
Thank you, Evelyn, and thank you, Katie, for such an insightful details and insights of what really is happening, as I say, behind the curtains. You know, we all in the business, I mean, your audience right now is spanning from 40 countries, is spanning from 430 cities in India. And I can tell you, a lot of us are in this whole trading and retailing business. And it's so important that all of us really get to know what's going on, get to know the very important steps that have been taken at De Beers. To do what? To all of us to be proud of this whole, gifts of Mother Nature that we represent. So thanks a lot to both of you to give us these insights. We have lots of questions coming in. And Evelyn, you mentioned that there's some paper that got submitted or issued in 2018 and some more articles. We'd love to connect with you to take them. And anybody who needs them or would like to know about them will be very happy to circulate. Thank you. And maybe I'll end with maybe start with, Evelyn, with you, your painting about the Kimberlites that you showed us. And when we were talking, you told me, when we say diamonds are rare, you also told me Kimberlites are rare. And that numbers are very fascinating.
They are, yes.
They're simple, they're very interesting. So why don't you tell all our audience about how rare even Kimberlites are?
Sure. So Kimberlites, they belong to a family of rocks. That's my favorite family of rocks. And I did a whole PhD studying these rocks, ultramafic rocks. And as I mentioned, on Earth's surface, they're pretty uncommon. So they only cover about 1% of Earth's surface. But Kimberlites is even less than that. I don't think anybody's actually figured out how much of the surface is covered in kimberlite because we haven't found all of them. But we spend a lot of effort trying to find Kimberlites, and scientists have found about 7,000 Kimberlites around the world, but only about 70 of them are economic for diamond mining. And only about 7 are really large mines, like we have Venetia, the mines in Botswana, those really big mines. So it is, when you have a diamond that comes from a diamond mine, it's coming from a rock family that's rare. It's coming from a rock type that's rare. And it's coming from a particular subset of that rare rock type that is even rarer. So it is really extraordinary to have a kimberlite pipe that has diamonds in it. So I just think it's such a great thing to be a geologist working with De Beers, because you get access to these incredibly rare, wonderful, magical rocks. They're really, really special.
Awesome. And I agree that this is true magic. I mean, we get to touch and feel these miracles of Mother Nature, which were born, I don't know when, billions of years. We can't even contextualize that. My next question is to you, Katie. A lot of people are asking us around questions around sustainability, and I'm just combining the question and making a wider one for you. So, in simple terminology, what is sustainability? And is this a big jargon or a big word that only De Beers can talk on? Or if I am a small retailer in a tier 2 market, can I also, start my journey? So if you can unravel this big word for us, Katie.
Yeah, sure, Sachin. I'll give it a go. I think, there are various definitions of sustainability more broadly. I think thinking about sustainable business, which is probably the focus of the questions, for us, being a sustainable business is being a purposeful business, also being competitive, resilient, agile, and I think most importantly is creating enduring value for all stakeholders. So when we think about our being a sustainable business, we're really thinking about listening to all stakeholders, understanding the context and the global societal expectations, and then really taking responsibility for innovating to come up with solutions. What can we as a business, what can we contribute with our resources, our know-how, the skills we've got to come up with solutions to meet those societal expectations and continuously learn, which we feel is a really important part of it. So I think any business can do that, no matter what scale, to really understand their own context, understand their own stakeholders and what their stakeholders are expecting of them, and continue to be striving to improve and become more responsible.
Fabulous. And I think only you reiterating a point that it's not just putting a tick in the box. It's not just a good thing to do. It's perhaps the right thing to do and think about future in this manner. So great. Thanks, Katie. Evelyn, my next question to you is, there are a lot of conversations in the group around how the government's responding to this. I mean, are they completely a partner? Are they an ally? And which industries are leading this whole conversation?
That's a really good question. So certainly in Canada, with the research that we've initiated there, we have co-funding from government, and we consider them to be a critical partner in developing this technology with us. Ultimately, if you wanted to get a carbon credit or something like that, the government would have to be involved. And I think it's important to have government partners as well, because there might be other rock types. Maybe there's old mines that are decommissioned, or other mining industries, small scale miners that maybe don't have the ability to develop this technology, but maybe they can learn from the De Beers work through government partnership, and these technologies can be applied to make all diamond mines have a lower carbon footprint, and maybe even other types of mines as well. So I think that's part of our vision. In South Africa, we've certainly had conversations with the South African government as well, with the South African Centre for Carbon Capture and Storage, and they're very much a partner. And we've also had some conversations with the Botswana government. Something we've emphasized to countries like South Africa and Botswana is that because they've had diamond mining and other types of mining there for a very long time, some places in South Africa, they've been mining diamonds for over 100 years. In Botswana, they have more than 50 years of diamond mining. They have a lot of tailings, historical tailings, that could potentially be used for that. And a lot of that is under government jurisdiction. So we'd like to share with these government partners, and potentially it might be an option they use to offset carbon for a power plant or for another industry. That could be a vision that we see in a future world. So we very regularly have conversations with government. It's really important that they're involved. And we've recently, through Anglo-American, also had some engagements with the US government, which is there are some politicians there who are interested in looking at potential in old mine tailings in America. So we've had some discussions with them as well. So we are absolutely very open about this and talk regularly with government and consider those partnerships to be extremely valuable.
Fantastic. And I think with the paucity of time, there are lots of questions coming in, but I commit to everybody who's posing a question that we will be writing back to you. But I'll end with Katie with last question to you. We talk about this whole carbon neutral strategy that we are working on as De Beers. So can you tell us a little more about that strategy and where we're headed to?
Yeah, of course. I mean, there's a lot of detail. We've been working hard on it. And as I said, it's got 4 key areas. Operational efficiency, moving away from fossil fuels, particularly in the truck fleet. Developing new renewable energy solutions through wind and solar and storage solutions for that, and then investing in the carbon storage like Carbon Vault. A really key part of it will be Anglo-American's Future Smart Mining program, which is really looking at innovation that will create a step change. So innovation like the hydrogen fuel cell trucks at the mines are really going to be the type of innovation and technology that is going to get us there. So it's a key priority across Anglo-American and De Beers. And we know that consumers really care and increasingly care. And we see, high engagement. Consumers will always care about many facets when choosing a diamond. But we do see increasing engagement when we talk about what we do on the environment, and particularly when we talk about investing in this type of new innovation and technology. So this is going to be something that, as an industry, I think we're going to be talking about more and more, and will become more and more important.
Fantastic. I think such a great insight. And I think for all the audience, I think all the interesting elements that Evelyn and Katie have shared with us will only help us bring real content that will matter to the consumers. A backside, a pillar that you guys can vouch for and say that there's somebody watching out all of this bit, and we can be more confident on representing these miracles of Mother Nature for occasions that matter and for feelings that matter. So thank you, Katie. Thank you, Evelyn, for joining us. It's a pleasure to have you here, and I wish you guys a great day ahead. Please do spend more time on the platform. We got a very good response on it, and wish you a good day. Thank you very much.
Absolutely. Thanks, Sachin.
Thanks very much for having us.
Have a great day. Bye.